Okay, so consider yourselves on the air if this actually works. So I configured it all according to the instructions and have zero confidence. But I'm hopeful. I mean, I'm okay. I have a little confidence. Oh, nope. There it is. It's working. I can see it. It's actually working. Woo. Oh. So it says there's 4 people watching now. One of them is me on my laptop. All right, gallery view. Those of you watching, we've never done this before, so we have no idea how this is meant to work. Oh, okay, I see. I changed to gallery view, and now I can see everybody. So somehow me as the host is controlling what the view is of the live stream. Okay. So it's going to be this will be all Drew. We'll just focus on Drew.
You should have been on 5 minutes earlier when I was frantically cleaning up the office.
Yeah, I did the same thing.
I don't know if I was very successful.
All right, the next thing here, let us record to the cloud. Cloud recording started. We're recording and we're streaming live. There are bits flying around all over the place. That is amazing. Those of you that are watching, ooh, there's 7 of us now. Very exciting. They will actually start talking on the hour about actual topics. But technically, we've never done this before. So the magic of technology. We're trying this whole thing, and it seems to be working out. So, all right. So that means we can spam the heck out of this thing. I mean, share with all of you in our loving audience the URL.
Can you hear me?
Yep,
Yeah.
we can hear you.
How's the quality? I think, no, it's still the microphone. It's still the roadie.
Just remember you're live, buddy. No fingers in your nose. You got to keep your shirt on. Not like our normal meetings.
I didn't get to eat. I had to go to the supermarket to buy food. Have we got an agenda today?
Yep.
Yes, we do.
No, we have.
Let me share that document with you, Mr. Farrell.
I can find it.
If you go into podcast scripts and go to the weekend edition folder at the top, you will find the script. Alternatively, you can look in the chat window where I just use the technology of paste.
Fancy.
So fancy.
So fancy. Not just fancy, so fancy.
See, when Ned joins us, then we can go, I think we'll go back to the gallery view. It seems that my Zoom control panel is the one that controls what the live stream shows. So if I set to gallery view, it shifts to gallery view. If I shift to speaker view, the live stream shifts to speaker view. So it's Zoom, however Zoom is doing it. Somehow it's relaying through through the host console view, I guess.
Did you come up first, I guess?
Oh, yes, I did. So I guess. So Greg, do you know what this is?
Sports ball.
It's a sports ball team. That's right. That's
Yes, sir.
right.
The only time anybody would put the language of Wales on a T-shirt would be if it's a sports ball team. Celtic is a language from Wales,
Yes,
which is
quite
a
familiar. Yeah.
which is a country in
Yeah.
Great Britain, or state, if you will.
Yeah, the history of this team goes back 50, 60 years, something like that. So I don't know why they chose it. I've never delved that much into that much of the sports ball history, but
Well, I think
Yeah.
there's the
Also the
Irish
language-
connection.
Irish, yeah.
Yeah,
Hmm.
identifying Boston as Irish because there's also the leprechaun fighting leprechaun logo. Yeah, there he is.
There he is.
Yeah,
So
Celtic language was Irish in Wales, Ireland and Wales.
Yeah.
In before the Vikings arrived, and then the French came through. As I understand it, I could be wrong.
Dare I ask what you're eating?
Fried rice.
Mm. Yeah.
looks good.
Which is really quick and easy, and it's just, and with the appropriate, a little bit of soy sauces, a little bit of pepper, and you can make anything magic.
This is true.
And it's also really good for picking out anything in the fridge that's kind of
Yeah.
not quite ready. Really should go in the bin, but you can just fry it up and nobody notices.
Frying forgives a lot of things.
Hmm?
Frying forgives a lot of things.
Mm-hmm.
Mm-hmm.
And it doesn't take long.
Gerardo from Costa Rica says you guys make networking more fun. And yeah, thanks, man.
Nice.
I mean, fun is relative, right?
I mean, when you're starting from zero, it's not that hard to make something one.
Well, fun. It's like my mind first goes to, okay, it's 2 a.m. This perf tile is blowing cold air right up the back of my shirt. And until I'm done configuring this router, I ain't leaving. This sucks. It's not fun. But I know what you mean. Yeah. Yeah. Again, we're Gerardo and the whoever else is watching. We're gonna start officially on at the top of the hour.
But thanks for being here with us on a weekend.
Watching Greg eat.
That's right. The audio quality on his chewing is exceptional. It's a good microphone.
High def fried rice consumption. Yeah.
Real good fidelity.
So Nick was going to join us and had a family conflict and can't join us after all. Tommy McNicholas is going to join us and he had a family conflict and can't attend after all.
Now it's just
So,
us.
It's just us, and I think Ned Bellavance is going to join us as well. So
I finally get to meet Ned.
you've not met Ned? There's Ned. Look at him. Ned, just so you know,
Hey.
we're live. We're live. We're streaming.
Oh, that's exciting. Wow.
It's all happening.
Great.
Yeah, yeah. It
All
it
happened so
immediately.
fast.
It did. Well, we'd never set this up before, so I was hammering around reading how-to articles. It's fairly involved, and to fill in the right fields in the right place and make it all so. But
Mhm.
but it's going. What the heck is on your shirt?
Jellyfish.
Jellyfish.
As one
Explain
does.
yourself, sir.
Well, I had an octopus one that I really liked, so I figured jellyfish was a natural extension.
Okay.
Do you
Should I
have
make-
more
Why
questions,
does it-
Banks?
Why does YouTube's putting Zoom branding all over it? Zoom is putting branding all over the YouTube thing.
It does seem so. Yep. I don't know if that's a checkbox or
Ah.
what, but I noticed that. It is fairly annoying since we're paying for the service. It's not like we're using it for free.
Oh, well,
It is what it is.
good. Now dinner's over. Gin.
Oh, good. Yeah, let's get you liquored up before we start talking about opinion things.
Excellent.
It's
That's
good.
better.
good.
That seems like a good plan.
Yeah, we need Ranty Greg to wind up and feel free.
Yeah.
Feel unleashed.
I'm curious
got
what's
topics?
in Ned's glass. Was that iced tea or beer?
Kombucha.
Kombucha.
Get out of here.
Okay, for
Hey.
the second time, explain yourself, sir.
Kick him off.
I blame Cloud Field Day. Ben got me to try it last time I was out there, and I was like, "Oh, this is actually quite tasty." So, I buy it every once in a while when it's on sale, and it's not bad.
So what is
I
it?
like
One of
it.
these fermented kind of drinks?
It's like fermented tea, basically.
Hey,
But
Nick.
no real alcohol.
Nick, I didn't think we were going to see you. You told me it wasn't going to work out.
Well, so that's why I joined up. I can't stay the whole time. I don't want to mess the flow up, so I can jump out if me leaving like after about an hour is problematic.
Okay. Well, that's up to you. You can check out whenever you need to check out. This is informal, and this is all a big experiment. So jump in, jump out when you need to.
Okay.
Stay keeping your significant other happy and all that. No worries.
Well, I mean, what I have to do is I got to get to the store and get some shiny gold letters that say Greg to hang in my office, and I got to do that. There's no getting around it.
Yeah.
Got to lift your game. Some people go with lower thirds. I'm going with upper thirds.
So Nick, we are live. We're on the air. There are some people watching, not a lot, but I think we're ready to get this show on the road. So Nick, did you since you just jumped in and put nothing into the show notes, let's put you on the spot immediately. Were there any topics you had brought to the table you wanted us to riff on?
Well, I know. So we could talk about what I did last week, which is go to FaucetCon.
FaucetCon. So this is the OpenFlow controller.
Yeah, it's the OpenFlow Python based. It's a Ryu app, and I went to the conference and talked about a lot of operational deployments and other things that have been going on in that space. It's that world's kind of died off a little bit. So,
well, I was going to say there's really a con big enough for anything that's based on OpenFlow at this point. I'm a little shocked by that.
I mean, it's a legit controller. I use it in production. It works, does what it says it's going to do. And, there's actually a fair amount of production deployments out there at this time.
So how many people showed up at FaucetCon?
I want to say there was like 60 or something.
Okay.
It was at the
That's
Google
pretty good
headquarters.
considering.
Yeah.
There's no brand names there. There's no marketing of the event particularly. It's just for people who are really in the know. So that's pretty good attendance.
Yeah, I mean, we had a good venue. It was at Google's headquarters, and there's reasonably good vendor support. Cisco's got their Cat 9K, the fully programmable pipeline, totally supports it. Works really well.
Can you get right up on your microphone? You're a little far away.
How's that?
Oh, listen to Nick.
There you are. There you are. Yeah.
So who's using Faucet? Is it research networks? Is it people
Nick
selling
and
stuff
59
kind of
other
networks?
people.
Yeah. Or are those 59 other people?
So there's some production networks that are like DOE labs that are using it. If you look at I can post a link to the videos. Sandia National Labs had a good talk. Good buddy of mine, Tim, is doing quite a bit with it. Kevin Myers from IP Architects did a talk on how they're doing a software-defined WISP, basically for traffic engineering. And then there's a handful of other places. It's really big in New Zealand because that's where the developers are. So you've got Allied Telesis is a lot of their dev work happens out of New Zealand. So there's a real tight coupling there. They've got really good support. They showed, and basically all the vendors that are supporting it showed up, and there's a plug fest at the beginning where basically you just hammer out any kind of, it's like a code sprint kind of thing.
Yeah, I sort of imagine that where we are with OpenFlow at the moment is people first of all tried to make OpenFlow literally like managing every single flow. And the way that I've been told that it's working now is it's much more like a static route. So you create static routes, but it's not just destination subnets. It's kind of like static routes for extended flow entry. So source, destination, TCP ports and stuff like that. So you don't create hundreds of thousands of flow entries. You create a dozen or so, and then you can apply policies to it. You keep it restricted, basically.
Yeah, I mean, it's much like in the early days when, you and I and a bunch of other people, late aughts, 2009, 2010, when you were like literally coding in every single flow entry into whatever. I mean, that didn't scale, right? It was a fun project, and it was very shiny, but like running it in production, when we did it for a little while and it was just nightmarish. Now,
so for the people who are listening, the way that it works is OpenFlow defines 14 different, is it 14? I think it's 14 different parts of a tuple, something like that.
Yeah, I can't.
And so you could define a flow entry by source interface, destination interface, source IP, destination IP, source port, destination port. But that's really dumb, because what you really want to do is create a flow, which is based like a route. An IP route statement in a router is a flow based on destination subnet with a mask in it, right? So if you're using OpenFlow to just emulate routing, you can program in a 192.168.1/255, and that's one flow entry. And if you start programming in more routes, then you've got more flow tables, right? More entries in your flow table. And at the end of the day, OpenFlow was always exactly the same as what a fib is. So you were just putting entries in the fib, and you're pulling them out of a rib and putting them into the fib. OpenFlow was always just programmed straight into the fib.
Yeah, I mean, it's much more refined now. Faucet allows you to do things like, it basically abstracts a lot of that away. So it creates a basic switching infrastructure, and really the thorn in the side of the early OpenFlow implementations. And the reason I think it didn't really ever come out as prevalent as, the marketing machine made it, was because nobody wanted to do multi-table, and to have real functional OpenFlow support, you have to support things like multi-table with next table and things like that, and very few vendors do it. And that's one of the things that really kind of drew me into Faucet, because I'd kind of written off most of that stuff when I got asked to go do the big OpenFlow network at Supercomputing last year. And I was like, wow, these guys actually have like a linter for their config. They have a test suite and an HCL, so like vendors can run their test suite against it. If it doesn't pass, it's not supported.
Right. Okay, so that's a big deal, right? There's been a number of companies that we've spoken to in the back channel, let's just say via unofficial channels, shall we say? And they've said if they were going to release an open source project and run it on white box, they couldn't validate it on every white box. So the way to solve that was to run a test suite and say, if this test suite passes, then our software would work for that. But nobody's ever done that. So this is kind of like the first open source project running on switches, which sort of has a validation test, which is if you run this will work on any white box that you tested on, and therefore it's compatible.
Yeah, I mean, and it's very robust. They've had it for a very long time, and they work really tightly with the vendors. I think there's 5 or 6 vendors that actually support it. And like I said, I mean, I've been running it in production for 18 months or something, and almost 2 years, and it works really well. I mean, it does exactly what it's supposed to do, no more, no less. You can have redundancy. You can do really creative things with the ACLs for, security reasons. And that's one of the reasons that I think Sandia Labs was interested in it. And you can go watch Tim's talk, but like it abstracts the control plane, so it makes the hardware a non-issue at that point.
But Ned, how about that idea, that metaphor around static routing is a fairly probably overly simplistic, but not. If you imagine a static route where you arbitrarily define, if you could do a static route by an access list, that's how I kind of think of it.
I mean, that's not a terrible analogy, really. I mean, you're programming a specific pipeline a specific flow entry into the pipeline, and it stays there unless it changes or the controller goes away, and then eventually it'll time out. But it's kind of a weird hybrid. So you're statically programming something, but it's dynamic in the fact that if the control plane becomes severed or you lose both of all of your redundant controllers, then it eventually fails closed, which is by design.
Yeah, that's what you want. You don't want the switches to run endlessly if the controller is out of action, because they might be forwarding into black holes. I guess the flip side here is, are you still running? One of the big problems with OpenFlow is people didn't want to switch off their networks for their legacy networks. They wanted to add OpenFlow to it. Does Faucet do that both? Does it still have spanning tree and BGP routing, or does it just do OpenFlow? Does it have just like an OpenFlow forwarding plane?
So it does. It will never do spanning tree. It does.
Okay.
It runs the algorithm, and if you're doing, they call it stacking, which I hate that name because it has a lot of negative connotation with it. That's not really what it is. But if
Yeah.
you're doing like their chassis type stacking, it has loop prevention built into that. So it solves that problem. It's not going to interact with legacy spanning tree, which I see as a positive because spanning tree is a bag of razor blades and hate. So
Well,
avoid
I
it.
mean, I was talking back in the old days when the idea was going to be that we were going to have switches that did everything. They were going to do all the stuff they used to do and OpenFlow. And that was the enterprise. Instead of saying, no, we're wiping the slate clean. Let's start again. Let's build up from flow-based forwarding and move up. And of course, the vendors all went, no, we're going to add OpenFlow so that everybody's got a migration strategy and we've got one product and that nobody has to make any choices. And of course, every time we say that you don't have any negative consequences, there's negative consequences. They should have.
You haven't found the trade-off. You haven't looked hard enough. Now, it will technically support, I call it hybrid mode because I think that's what Juniper called it. But the recommended deployment model is just like you said, it's all OpenFlow or it's no OpenFlow. And I haven't actually messed with the hybrid stuff because I figured if I'm going to do it, I'm going to go in whole hog. And I haven't had any issues. And I've got legacy gear that touches it. And it just, I create a tag, it's just basically a trunk. And that's the demarcation.
It's really hard to explain how that would work to people without a whiteboard and
it is.
It is.
And as far as like BGP and stuff, everything is considered an FV service with Faucet. So when we built the network at Supercomputing last November, we did we had Bird off to the side and some middleware that would take a full BGP feed in, convert it to flow mods, push it in, take the flow mods that existed in Faucet, convert them to BGP routes, and announce them out. So it just sat off to the side and did BGP. And then, DHCP and things like that were all just considered NFV services.
Yeah, that makes sense. That would be not non-trivial, but that was the idea behind OpenFlow back in the day. But nobody in that era could understand it. Customers couldn't understand it. Vendors couldn't understand that idea. And I couldn't get through to people. People just had this idea that it was going to be another protocol. So you add it on. You don't start from scratch. And
Nope. We're on the
same page. You don't need
page.
MPLS. If I was a telco, I would not use BGP and MPLS to do my network. I'd use Flow. I'd use some form of OpenFlow to program it because it'd be simpler.
Yeah, we prototyped that quite a bit in my job. And what it came down to is we ended up with the conclusion that we would have to have a controller, like some international network. We'd have to have so many controllers that it didn't really make sense for us to manage it. It became extra overhead instead of
so many controllers in what sense? Just because of geographic diversity and where you need to position controllers for it to be redundant and latency and all that? Well,
so the latency requirements of OpenFlow, just imagine taking like a chassis-based router, pulling both of the REs out of it, or the CPMs or the SUPs, pick your vendor of choice's terminology, and shoving like each of those on two sides of a country, right? The round trip time and so all the wacky stuff that goes along with pulling that out just made it very difficult to justify it as a supportable model. Whereas if you say put a controller per POP or per colo facility or whatever, that made more sense. But at that point, you've functionally doubled the amount of elements you have to manage.
They're like a controller of controllers.
There is. So one of the other major NRENs, National Research and Education Networks in the US, actually started building a controller of controllers, and I piddled around a little bit with it, and it didn't. I wasn't able to make it work the way I wanted. At the time, I think it was only OpenFlow 1.0, which is a non-starter in my opinion. So
not enough flexibility. Yeah, I guess, that is ultimately the bigger problem here, is getting controllers to sync and to be coherent is actually a substantial challenge, because, and this is where BGP actually does work, is that you can distribute BGP around the place and nobody minds that it's eventually consistent. Like you get this random sort of effect in BGP where it doesn't work, but when it does, everybody goes, that's just BGP. right? But if your OpenFlow controllers were eventually consistent, people would be going like, "Oh my God, the world has ended. That doesn't work. It's a failure. It's a failure." You know?
Oh yeah, I've had inconsistent controllers where I thought I rsynced the config over and didn't, and it was really, really bad day.
But that's no different to BGP on a bad day, right?
No, but so I'm used to that, right? Everybody knows what the BGP
right.
sweats are, right? You get the
That's my
BGP
point,
sweats
right?
about a minute before it's actually done, which is when you think it's going to be done, right?
Yeah, that's right.
It's kind of like the meat sweats, except for it's BGP.
Far less delicious.
So Nick, we got a question in from Ong who asks a question that you might have some input into. He says he feels like networking technologies is just a lot there these days, so much more to know than there used to be, and there used to be a lot to know. So it's even worse. Anyway, the question is, I am trying to focus on service provider technology. So if he wants to focus on service provider technologies, what are the new things to focus on?
So service provider world, which is where I spend most of my time, there's a couple of things coming up. Like, really, you got to know your routing fundamentals, right? I would recommend that you learn ISIS as your routing protocol, because it scales larger than, say, OSPF does in a saner way, in my opinion. A lot of large carriers will use that as a protocol. It also allows you to run multiple protocols in the same routed protocol and doesn't rely on the protocol it's routing for communication. So I would learn that. Segment routing seems to be, SRMPLS seems to be the thing that is the up and coming.
Did you just kick SRv6 in the head?
Well, SRv6, I absolutely love the idea of it because I am a very strong v6 proponent. Mm-hmm. But as you can imagine, stuffing however many 128-bit addresses into the header is going to cause hardware problems, right?
That's going to get better though. So SRv6 Plus and the proposals there are going to, I think, compress a lot of that data. Although I can tell by the look on your face, Nick, you're going, nah.
I mean, now I got another box out there to manage that's doing all the hard work, right? I mean, the SRv6, whatever it's called, the box that the plus box that maps things.
Yep.
I really think, and for the foreseeable future, SRMPLS is probably going to be, because I can run it now. Like, I am running it now.
Yeah.
And service provider mean time to replacement is typically 7 to 10 years. So,
do you know the interesting thing about SRMPLS is it's basically OpenFlow just using MPLS tags. It's static routing with MPLS tags. That's literally what it is.
Yeah, I mean, it's
source routing with MPLS tags.
Yeah, source routing with MPLS. You're pushing your label stacks down, and even that has hardware limits, right? A lot of the label stack depth on the hardware gear is on the service provider gear is going to be 12 to 18 labels. So if you've got an international network and you want to do explicit EROs, you're using binding SIDs and stuff, and then that becomes a little bit more complicated. And also,
I'll tell you where it's really going to become complicated is SD-WAN is causing sort of this collapse in MPLS where customers are putting SD-WAN onto MPLS and internet and finding that internet works better than MPLS and then switching off their MPLSs. And the prediction is that the roll-off on MPLS is going to be very rapid, all right? And at that point, telcos are going to end up sharing their MPLS backbones because there's not going to be enough customers to justify running one yourself. But if you can only run 12 MPLS tags, you can't do carrier to carrier with SR MPLS because you're going to have to, like, if you want to run, you know how most mobile phone companies don't actually own their towers, they actually share them. Mm-hmm. So in the UK, there's only 2 companies running mobile phone towers. And one of the companies is jointly owned by 3 of the telcos. And every time you connect to a tower, it could be a tower, right? And the long-term strategy for MPLS, in my mind, is going to be they're going to have these MPLS networks, but they're not going to be owned by the telcos. They're going to be owned by a third party because they just can't run them themselves. You can only justify MPLS when everybody's using it. And if you get to the point where enough customers just say, why am I sending traffic on an MPLS? I'll switch it off. Then all of a sudden the MPLS services collapse because there's not enough scale. There's not enough volume to have them.
Well, I've never been a huge proponent of private MPLS overlays just because you can. Like in the early days when I was doing service provider work in the 90s, basically it was IPsec, it was poor man's SD-WAN, right? Yeah. And I have had many arguments with many people that I think SD-WAN is just lipstick on a pig, right? It's all the same protocols underneath with a fancy GUI on the top that makes it easy to use. And that's cool. And that's got very, very clear use cases. But the fact that people are turning down these, these MPLS services that are like dedicated VPLS overlays,
Yeah,
and
the
things
private
like that,
WAN stuff.
unsurprising to me. Like I smelled that
Yeah.
coming along before the SD-WAN phase.
Well,
came.
that version of SD-WAN's already obsolete by and large, and we're talking about, maybe we'll talk about it today, maybe we'll talk about it some other time, but to my mind, the first generation of SD-WAN was this dynamic path switching over IPsec tunnels, right? Or SSL VPN, just depending on your vendor. And that's already obsolete. And the next generation is where they're putting security services over the top of that. So if you're going to have a router at the edge of the network and it's an x86 box running Linux, why don't you just run a whole bunch of VMs that, or services like firewall and threat detection, malware scanning, content inspection, content logging, user authentication. And that's already here. The companies that are doing that are already here in SD-WAN. So all of a sudden the router is like, that's a telco technology. Forget that. What we want is an x86 box at the edge that does all these other things. And that's the emerging play in SD-WAN. And path dynamics, this automatic failover becomes like table stakes. It's already table stakes.
Yeah, no, I don't disagree with that. I love that. I love that model. I do think that there is definitely a market for SRMPLS or any SR technology for that matter in the market of the telco space, regardless of who owns the footprint, in allowing for NFV services, right? So if I say, well, I've got this whatever, I've got a 1 gig circuit to my data center or 10 gig circuit or whatever, and I want DDoS protection, DDoS scrubbing over it, very trivial to use SRMPLS to push the label stack through a scrubbing system, right? So,
yeah.
And the overlay stuff is typically not managed by SRMPLS, like the big VPLS overlays. That's a different thing. And I definitely think that so
what you're saying there is that if you've got an MPLS enabled backbone, you can give people EO MPLS or VPLS service, Ethernet MPLS services over here. You can give people IP MPLS services, and that's got value. My point is that if people just move to the internet, then that all becomes largely redundant, right? If you can sync.
I don't agree with that, because I think that the internet is going to be abstracted away on top of these carrier networks that are doing traffic engineering via label switch paths, right? They're not going to buy that service, that overlay service anymore. But if I've got, 2 paths and I want to maximize both of them, this is kind of the OpenFlow thing again, right? Where I want to run all my WAN circuits as hot as I can, right?
Well, that works if I'm doing business with just one telco. But I can't trust one telco to do things right. So when I'm in an SD-WAN environment, I have multiple telcos, right? So mainly because the telcos suck so bad, right? So if that's the case, then I don't want my telcos traffic engineering. I just want them to build as much bandwidth as possible, which then runs them further into the ground because they have no value to it. You as an operator might think you could tune your bandwidth by do traffic engineering. My point is that traffic engineering is a complete waste of time because nobody cares. Everybody just wants to put their traffic on the internet. Stop traffic engineering. Just let me get on with it.
I think you're talking about it from the enterprise perspective, and you're right. Like nobody cares. They just want a fast pipe. They don't typically care about the amount of hops or anything like that. But the folks that are running the backbone providers, whether they consolidate or not, they care about where the traffic is hot and where it's not. And that's where they will use the tools that I'm talking about to steer the traffic around, which will be totally transparent to the end user and give them exactly what you're asking for.
That makes sense. Hey, Ned, quickly getting back to the viewer's question about areas to be interested in for service providers. Have you been looking at any of the service provider projects coming out of the Linux Foundation, like OPNFV, ONAP, that kind of thing? Is that someplace to know?
No, I haven't looked at any of that. Where I think there's a poverty of great people is folks that understand automation at scale. And, network to code folks are really helping to change that, turn that around. But at the service provider level, that's something that they're much slower. And so having the ability to understand automation platforms and how to do that at scale across large geographic areas where it's a truck roll if you mess it up, that's important. there's definitely a lack of folks that understand optical substrates. So, DWDM platforms are becoming much more prevalent, not only for inter data center connectivity, but also, as more and more fiber goes into the ground, something's got to light that up. And, that's a very specific skill set that there's not a lot of. It's hard to get too. That's the other thing.
Well, there's a few things going on there. One is, if you're building an MPLS network, the biggest problem you've got now is you can't make IP routers big enough. Like terabit class IP routers are still emerging that do MPLS. Although you can do it in Broadcom ASICs at 12.6 terabits per second, most people actually aren't using that. They're still building using those legacy chassis routers that the big vendors have got, the PTX and the Cisco CRS and that sort of stuff. And really, those people would be better off just using a white box because they get more performance for less money. But it would cause them to re-architect their network substantially. So not a trivial exercise, right? But what I am seeing is, for example, a lot of routers now have optical line cards in them. So instead of the days of the router had all Ethernet or all ATM or all fiber channel, nowadays you actually get these line cards which are optical, and then you just run them straight into a DWDM switch. And a lot of those DWDM switches are a lot easier than they used to be. Like once upon a time, those things were fairly arcane, right?
I mean, they're still fairly arcane. They're just not nearly as horrible as they, it's not a Windows Java app that you need to run it anymore. But you're right. So the packet optical is the term that I've always used to, so you're putting colored optics in a DWDM blade in in like an Juniper MX or a Cisco, what have you. I think there's going to be more and more of that as the mean time to replacement goes on, because as things like open line systems become more popular, which basically an open line system is, you have a shelf that's your optical shelf that controls the transponders, and the transponders may or may not be from that particular vendor. Historically, it's the old model of, if I buy vendor X, I have to buy optics from vendor X. DWDM platforms very much the same way, except for 100 times more.
Yeah, and so, most of the magic's in the ROTM or the transponder.
And
ROTM/transponder.
It's in the transponders and the ROTMs, and as open line systems become more and more deployable and obtainable, I think that having that optical knowledge is going to be more and more important, because you're gonna end up saving on transponders, and you're going to end up having a converged optical routing platform so if you've got the skills to understand the layer 3, the layer 2, and then the layer 1 as well, then that's a pretty big toolbox to draw out of when you're looking for jobs.
So if people are listening, there's an most excellent presentation called Everything You Ever Wanted to Know About Optical Networking But Were Afraid to Ask by Steenbergen. I'm trying to think of his first name. Richard Steenbergen. And he presents it at NANOG every 3 or 4 years, I think. Yeah. And it is, I'll be honest, that's where all of my optical networking comes from. And that's not quite true. That's a slight exaggeration. But if you read that, I've put a link in the YouTube chat, and we'll put it into the show notes at some point. But it is a truly wondrous introduction to the physical. About 50% of optical networking is understanding physical, like how laser light propagates down a glass tube, and how the wavelengths work and the overlaps. It's a bit like Wi-Fi. If you want to understand optical networking or Wi-Fi networking, you have to understand 50% of the physical before you understand any of the logical. So it's a fantastic presentation, and the deck is there, and he also has a YouTube on NANOG. Go to the video on NANOG, which is on the YouTube, and you can watch it, and you'll just have so much. You'll just learn so much in a short period of time. It's brilliant. I really highly recommend it.
That's an excellent resource. And if I could add one thing to that, the one thing I learned, I don't really touch the optical gear much anymore, but when I used to do it, the one thing that I learned was more important than anything else in that space. 2 things. 1, never turn on the Raman amp with nothing plugged into it, because it burns up immediately and you have to get a new one, and it's probably about $100,000. And two, learn how to use a cleatop to clean and a proper scope to scope your fiber, because 9 out of 10 times, the reason it's not working is because it's freaking dirty.
Yeah. Physical. 7 out of 10 network failures are physical cabling faults, and especially in the optical network, it usually is.
Absolutely.
It's pretty interesting.
Micro bend. You see a fiber that's bent just too far, you can actually watch the OSNR change.
Yeah. I think we'll see a lot more optical networking, simply because if you've got, like they're talking about now, 400 gigabit per second optical transmitters, and if you've got 400 gig signals on a single wire, that's an awful lot of traffic that you have to route in a router. Okay, so the real thing is to you can't route IP packets at that sort of scale. Like if you're at petabit scale, you can't route IP packets. So it makes more sense to replace the IP core with an optical core. Okay, so that you're actually just routing the packets at the edge, but trunking them over an optical core at high speed, and that's the likely future. Instead of this, the last 20 years of migrating to IP everywhere is probably finished, and we're going much more towards an optical core with an IP edge, and they'll be routing at the edge, but optical switching in the core.
I can tell you for sure that that's the future. I have no doubt, because we're basically doing that now. It's we call it hollow core.
Okay.
Yeah,
that's pretty painfully obvious to anybody who's watching the industry. So I sort of started talking about that 3 or 4 years ago. I was fairly sure that, IP routing doesn't scale. It just can't. You can't bring a packet in, read it, recalculate the CRC, and then send it back out on the wire. That's just, at 400 gigabit per second or 1.2 terabits per second, that just doesn't make sense with the current silicon that we have today. The silicon tomorrow will be different, but hey,
Tomorrow's tomorrow.
Hollow core sounds like an emo metal subgenre.
It probably is.
It really does.
Go on Bandcamp and search for it.
Yeah, I want the trademark if it isn't yet.
So, Nick, you could finish your thoughts up on the changing world of the service provider for Ong with one follow-up question here. He says he's gonna keep digging into MPLS and go into segment routing as well. But what about layer 3 VPN services? Do those go obsolete because SD-WAN is coming?
I don't know. I mean, I think that the ones that are there. So L3 VPN to me is that's boutique net stuff, right? You got to have a very specific reason to do that. But I do think that as the service provider worlds evolve, the overlays like the L3 VPNs are not going to necessarily go away. What I think you're going to see go away is the VPLS overlays in favor of fast,
today
raw internet access.
Yeah, today carriers offer Ethernet services, and that means you can do DCI over them, so you can extend your data center to data center. And if you want to route over them, it's up to you to be smart enough to route over the top of them, which is what you should be doing. But the telcos chose to give you Ethernet so they could sell more stuff to idiots, right? Because there's plenty of idiots, and that's what that's literally how they said it to me, by the way. I've actually spoken. They go like, yeah, it'd be stupid to do Ethernet, but there's plenty of stupid customers, so we've got to have stupid products to sell to stupid people, right? So the point is that if you give Ethernet, you can route IP over it, and that's up to you to be smart enough to route IP and not use Ethernet and get the looping, the bridging loops that you have. And increasingly, people will stop buying that as SD-WAN replaces the need to, and cloud too. So we're starting to see things like data center interconnect technologies over layer 3. So vMotion can be done over L3. And with the arrival of NSX for overlays in the data center, we don't need Ethernet for DCI because NSX has an overlay. So when you vMotion a VM from here to here, the underlay doesn't have to keep the network coherent, the overlay does. And that changes the nature of the process. So over time, if the DCI market will fade out slowly, which is what will happen, and keep in mind that if a market doesn't grow, it's dying. As far as business is concerned in the current either if DCI stopped where it was and stopped growing and just stayed with the same amount of revenue, that's not enough for telcos. They have to grow or die. And so if it's not growing, then that technology gets phased out for something that grows, and L3 VPN is growing. That's what people want. And it's also substantially cheaper for vendors to put L3 VPN in than VPLS. VPLS consumes a lot more resources in the backbone, if I'm right.
Yeah, I agree that I think that the VPLS stuff is is sort of is sunsetting right now in the from the business perspective, right? Because like you've said, they just want fast internet and they're going to run whatever the overlay technology is over that. And the overlay stuff is becoming so easy to use now. It's literally just I put a box in and I push a button and it's done. And so where I think the L3 VPN things will remain is within the service providers themselves for carving out route tables and things like that. I don't think they'll continue to offer that as a service, at least maybe in the next 10 years or so. That'll phase away. So because that's X amount of route tables they have to manage, right?
Another question that's come in here, Abid asks, do you see any major application of data science in network engineering? So if we talk about data science as in there's lots of numbers, data, et cetera, that we're needing to do something and apply it to networking. I think if we talk about AI and ML as part of this, the answer is sort of. The problem is actually mapping data sets in a useful way to a machine learning algorithm so that you can do something with it. ML relies on lots and lots and lots of data so that it can learn what the trends are and then react to those. I'm not even going to get into what artificial intelligence might mean for network engineering because I don't think there's much of anything that's real there right now. But I think that's where the data science aspect comes in. There's lots and lots of data that are coming off of boxes now, more than we're way beyond the world of SNMP and polling stats and then graphing them. Now it's streaming telemetry coming off of the boxes. We got a number of ASICs that are out there that can send real-time telemetry off of that ASIC and into some kind of a collector that does something with it. How are we going to do something interesting with that data other than collect it and graph it? Well, you're going to put it in a time series database. You're going to apply ML to it and then see what you can pull out of it. And I believe that is data science. There's some startups in this area that are working on this. There are some startups that are doing not just network engineering kind of work related to this, but are bringing in all parts of the IT stack into one. And in some of the cases, network data is actually the afterthought. That's happening there. And then the question is, what is the end result? What do we actually do with this data if we're getting all this telemetry and trying to make something happen? And I think the answer to that is trying to get an algorithm that recognizes something interesting and happening on the network and then reacts to it in an appropriate way. That's one issue. Another answer is you're looking at all the data that's on the network and finding trends that are of interest to a business. So a business is going to try to harvest that information to make more money because they're going to get insights that they wouldn't get otherwise. In other words, the data science is going to replace what a human looking at a trend line might be able to infer because the algorithm is going to do it much better. So was that an application in network engineering? I'm going to guess it'd be that's what you were getting at, something like that, but still all emerging. So I just ranted for 3 minutes, so I'll let you guys add in. Some of you were nodding, some of you were shaking your heads, so feel free to tell me how wrong I am.
I would push back on the replacement of the person because it does it better. I think it just
you
does
just
it
feel
faster.
Threatened, Ned.
Well, I mean, the machine apocalypse is absolutely coming. I don't think we can debate on that. But aside from that, I think what we're really looking at is it just allows the calculations and the trend lines to be formed faster than an individual analyst could do. But you still are going to need that person that can infer from the analysis that the machine learning tool does what actions to actually take. There is that sort of like artificial intelligence component, which doesn't exist yet, except as vaporware. That would be the component that actually can look at the machine model and the output of it and make an intelligent decision about what to do. And that's when the analyst actually gets replaced. But AI is nowhere near there. And we've got to be at least 5 to 10 years away from it.
We don't disagree. More. We're only disagreeing on timeline. That's all. How long it's going to take. And I don't even know that we're disagreeing there because I think the outcome ends up as the same. That is, ultimately, there is going to be a predictable set of actions you might want to take or inferences that can be made, and the machine learning algorithm and maybe the AI after that will be able to make them given enough time and enough data. So it's just how long is that going to take? And depending on which AI experts you talk to, that's like real soon or 10 years plus, we have no idea what's going on. We don't know how any of this works.
Yeah,
I've never
there
heard any
needs to be
vendor say,
that.
I don't know how any of this works. They're ready to sell you something right now.
Yeah. I think there's a few things. I wrote a white paper on this, which is published on Ignition. And yes, you too can be a member of our Ignition website. Cross promo, time to promo the Ignition membership platform. No, I wrote a white paper, which is about, 4,000 words on AI and ML and what it's going to be looked like in the future. And I agree with you, Ethan. True AI that makes decisions for you is going to be 10 years away.
Yeah.
There's going to be machine learning, which is going to give us something in 3 to 5 years. And today, most companies are delivering something based on what they call deep learning or statistical regression. And those are all different types of mathematics. They're quite varied, different mathematics. And once you've got the basic mathematical theory, they then have to turn that into something that computing can do. You have to program it. You have to have data. And so the way that it's going to work is they're going to call statistical regression artificial intelligence because marketing can't help it, right?
Yep.
And the people in marketing go, is this AI? And the people go, well, kind of. And they go, it's AI, right? And that's what turns into the market.
You didn't say no.
Okay, you didn't say no, so it is, right? So what we're seeing is a lot of stuff called AI. We're seeing a lot of stuff which is called intent-based networking, which isn't. We're seeing a lot of stuff called software-defined networking, which isn't. But that's normal. You've just got to be a smart buyer, a smart consumer, and know what to buy and what not to buy. And today what we're doing is a lot of good statistics because the data source that we've got coming off the boxes is streaming telemetry, gives us the ability to do decent statistical regression or linear regression for the first time. And we can also start to apply deep learning to that to start recognizing paths. But ML and AI, that's a way out in the future stuff because, you need a hell of a lot of compute and resources to make that scale. We don't have the data. We don't have the training data, right?
So I mean, that's slowly changing, right? Because you've got a few platforms out there that are collecting customer data with permission. They're typically an opt-in scheme. They're collecting that data and doing the analysis in the cloud. And now over time, we're slowly but surely gaining data sets. It's not the problem it was 2 years ago. It's still a problem. I'll give you that. But I think that over time that's part of what was in my head is that's taking us down this path of actually getting to a point where ML and AI are real and not just, you didn't say it wasn't machine learning, so it is. We're stamping that and putting it on the box.
There's
you can't blame the vendors. Sorry, go on.
No, I was gonna say there's definitely a lot of marketing hype around ML, and I've seen we've got some folks working on it. And the hard part about networking in that is that sure there's a lot of ways to get the data, but figuring out what's useful in that data and what to feed into your unattended learning and then pulling things out of that is much harder than a lot of the hand waving that I do that it's like, hey, it's machine learning or whatever, and it's difficult. And then once you're over that hurdle, that's when, you get I've learned this thing and now I can do this thing, without any human intervention. And I agree. I think that's probably at least 7 years out.
Well, there's another piece of this that has been concerning me, which is the snowflake networks that most of us run. Everybody's network is different. We can argue about whether that's bad or good or whatever, but realistically, everybody's networks are different. So do we have enough commonality across networking as a discipline and across all the way that we've implemented our networks that the data sets that we're contributing to through our products and what we're sharing with vendors and so on, is that going to result in a common data set and point of view from a machine learning algorithm standpoint that is going to be universally useful? Or are we all going to have to train machine learning algorithms on our own networks from our own snowflake point of view for those to be useful?
So in my opinion, like you said, every network is a snowflake. And to make a universally useful data set, you'll have to distill it down to such basic building blocks that you may not even really let's talk about that. Like, what can you pull out of that? Like, you can maybe help define and notice gray failures. That's hard to do, right? That's always been on the top of my list of things, but it's hard to get that data, right? It's a combination of a bunch of different stuff that's going to point you at the fact that you've got like a gray failure going on. And for anyone that doesn't know, gray failure is when it's broken, but it's not really broken.
Yeah, it's the one packet in the port channel. There's the one optical in the port channel that's dropping packets, and it's the weird stuff.
Or an optic is failing, so like the amount of TX and RX is changing and getting worse, but maybe gradual. It may go back and forth. That kind of stuff. I think that's such a huge amount of different inputs. They're going to have to go there, and then you got to figure out the ML algorithms to actually suss out useful information.
And it's not going to be algorithm, is it? Now that we're talking about this, it's going to be algorithms, because it depends on what you're looking for, what you want that algorithm to do. So, for example, one of the big use cases here is with security. Security looking for anomalies within traffic, and the anomalies in that traffic are going to stand out because of how the algorithm was set up to whatever it was looking for, what it's comparing against, what the data set is. Oh, you're experiencing a DDoS attack or whatever it is. Which I think is different than looking for gray failures, which is different than looking for data exfiltration, maybe, which is different than, and on it goes. I mean, so it's not like you can have the one size fits all ML algorithm that's going to tell us all the interesting things we want to know. It's going to be like defining an automation workflow. Well, how do you do it today? Well, what do you want? What do you want to do with your automation? I want to automate the network, Oh, come on. You gotta be very specific and understand what it is you're trying to do. I think that algorithm is going to be the same thing. So going back to our data science point, we're going to have to be mining data in a way that takes us to what it is that we want to detect. And it's not going to be any one thing. Yeah, I spread some ML over the network and now it's better. It's going to end up being very use case driven.
Yeah. But I'm reminded of malware, like on desktops and PCs, where they first started out they got very excited about pattern matching. And if they could scan your hard drive or the network for this pattern, then they knew that there was a virus coming in, right? Or malware was coming in. And then they developed heuristics, which is a different family of maths from pattern matching. And that turned into,
slowing your Windows machine down so it didn't work anymore. And we remember.
Right. And then it went on to fingerprinting, and then it went on to, and so now you have, all these different methods to determine, which is a combination of different, and that's the way networking is going to go. It's just we're a lot further behind in that sense compared to, those technologies.
Why are we always behind, Greg? We're always behind in networking.
That's because the network works. We're not incompetent like Windows,
Yeah, you want to let everybody else make the mistakes, right? And then learn from them. And Windows has made so many mistakes.
Yeah.
The other thing is, your Windows machine or your PC or whatever it is, right? It's a known quantity, right? It's running this operating system. It's probably running these applications. It's got memory. It's got a network card. Whereas the network is largely defined by what traffic it moves around. And that varies dramatically based on what kind of network it is. Like if you looked at the traffic on the network that I work on, it looks like a DDoS attack to everybody else, right? You're seeing 60 gigabit single flows. It's a very different model than, say, Comcast network, which is a whole bunch of small flows with 1,500 byte MTUs.
And it's also, if you lose a Windows machine, nobody bursts into tears. You lose the network, everybody's bursting into tears.
Right.
The person, one laptop versus 10,000 people in a campus. It's a scale problem. Networking is always behind because of that federated, distributed nature of it. You can't.
It's a blast radius problem. Yeah, you screw up the network, and the impact can be in many cases huge.
That's the first part.
Everyone's scared. Yeah.
I would be
supposed to because the network is
Windows box, people clap. They don't cry.
But the second part about it is the network's so distributed. If you wanted to change it, like if you want to upgrade BGP, what would you have to do? You'd have to replace every BGP router in the world, the code at least, if not the router, right? Yep. So if there's a problem in networking, funnily enough, we can withstand it a lot longer than a Windows machine, because you're not going to fix that in anything short of 2 decades. And that's why BGP hasn't changed in, 2 decades. And
we just need one big BGP flag day where the entire internet goes,
yeah, that's it.
And it's fine. We have new features now.
That's an excellent suggestion. We should take that.
Didn't work.
We should take that to the IETF and get that. We should get that. That should get legs. That's what we need. That's big thinking.
Keeps telling me I need to get involved with the IETF. Maybe I can go and
Nick's BGP flag day proposal to implement new features.
Yeah, it'll be just like IPv6, except for if it doesn't work, nothing works.
That could be awesome.
Okay, another question from Ong here. Thank you for the questions. Keep them coming. He says, how did you guys learn network security, and any suggestions for the starter who wants to learn? Learning network security for me was from an engineering perspective, where not only did I have to deal with routing and switching and whatever else moved packets, these firewall things move packets too, so it became my problem. So that's kind of where it started for me, firewall administration from a very early day. And then it became more than just building out rule sets, but understanding the way attacks come, understanding it's more than just 5-tuple, it's what happens in payloads. And then at some point saying, hey, we need more than a firewall, but getting involved with intrusion detection, and then studying up on that technology, adding that as another layer. I got thrown into the fire 20 years ago dealing with a virus outbreak, for example, and had to deal with the virus that was spreading rapidly across the Microsoft Exchange server and Outlook clients, and people clicking on things they shouldn't have been clicking on, spreading, then having to do a massive recovery and dealing with that, and then adding on a layer 7 to the firewall and IDS mix, which was a virus inspection sent out globally. So it was a mix of, we have to have a firewall, this is your problem. And it was then, bad things happening, and then just kind of going from there. And it becomes this deep, dark well of bubbling lava. How deep do you want to get into security and deal with it? I was a Windows guy and a Novell guy back in the day. You get security from yet a different perspective there, dealing with file and print services. So operationally, there's just a lot of ways you can get into it. And SecOps has evolved now. I mean, I think it's a pretty different animal from what it was. It used to be this practical thing that you had to do because you got to be secure and have a password policy and whatever it was. And now it's this mindset. It's a way of looking at network information. Cyber warfare is a real thing where nation states are actually acting against one another. Corporate espionage is a real thing. We are actually looking for data being either stolen from your company or actual bugs, viruses, spyware being installed on your network because someone's trying to take that from you. And so the way it ends up being you understand a problem, then you learn how to defend against it. And then there's a new attack that comes up, and you understand how that works, and you learn how to defend against it. And along the way, you pick up new technologies that might be invented to deal with it. So that's an operational way of looking at it. How do you get into it? Start with a firewall, man. I think that's the easiest way. Start with a firewall and kind of add on from there. The firewall is the basic thing. That's filtering. It's a control point. There's logging and auditing that you can do at that point, and then add to it. You can end up adding encryption and adding. There's so many services that you can just end up adding. But if you understand a firewall and the fundamentals there, that's as good a place as any to start, I suppose.
I would say. Go ahead, Greg.
Go ahead, Drew.
Yeah. I would say I feel like I see the security industry and security professionals transitioning from a prevention mindset to a response mindset, meaning we're going to do our best to keep stuff out, but we know something's going to get in. And so we have to have the visibility, the awareness to spot it as early as possible and then remediate as quickly as possible. So in addition to that firewall thinking, you also need to be thinking about logs. You also need to be thinking about auditing. You also need to be thinking about visibility and that sort of day-to-day monitoring, vulnerability management, all that stuff, so that when something happens, and it will, first you know that it's happening, and second you can go figure it out and stop it, and then remediate as quickly as possible.
So I got into it by osmosis. So at the network needed a firewall, so I used to put the firewalls in because they were part of the network. And the people who configured firewalls back in the mid 90s couldn't even spell IP by and large, and so it was a real. Like they didn't know what an internet was, but in theory, they were firewall experts, which was loads of fun. And then I found traditional networking to be pretty boring. So campus networking or IP routing in the WAN got very boring very quickly because it was the same thing over and over. And I spent most of my time working on those networks. Well, it wasn't working. Most of the time, I just sat there like a fireman waiting for something to happen. And then when something happened, you run out like a fireman and you fix something. And then you run back and go like, training, I'm going to clean all the hoses. I'm going to check the fire machine, try to check the fire engine. Pretty much that was what my experience of campus networking and WAN management and data centers was. And then every now and then, once every 5 to 10 years, you'd have something really exciting would happen. And so I decided to go and play with the firewalls, and that led me into playing with load balancers. And then I got into application networking and load balancers. And then once you're in load balancers, you can start to fiddle around with proxy servers and IDSs and content, and then seams and all that sort of stuff. So it's just a question of being around the network. And then when people ask you, how do I add security to the network? Put your hand up, volunteer, get stuck in, learn. I can remember reading some fairly arcane manuals like of devices that are long since defunct, like doing SSL termination, and do it on devices that did hardware key encryption. Like they were security inspection devices that were load balancers that had hardware security engines on them where the keys would load. And I learned a lot about public key cryptography from trying to make those go and that sort of stuff. So for me, and I spent most of my life fiddling around with security in the network, not actually networking professionally. But that's because the people who did I was asked to come along once every 5 years and design the network, and we'd sit down at a whiteboard for 6 months and this is what it should look like, and then get the vendors in the room, and we'd waste months having meetings and lunches with vendors. And then after that, it got very boring after a while, and I'd just leave the other people to go and do it, and I'd go back to my firewalls where I was having lots of really good fun. Yeah.
I got in it very similar, basically was networking, and then somebody came and said, we need somebody to look at these, checkpoint boxes that were purchased running on So I knew Unix at the time because I learned that
on Solaris.
It was running on IPSO. So there were Nokia boxes,
okay.
BSD based. And I just happened to be FreeBSD guy from the mid 90s. And so they're like, well, now you're also the Unix guy that does the security stuff. So I did, network flight recorder. I'm dating myself here. Checkpoint. And some other things.
I'm going to have a fit here in a minute. I'm going to go to a post-traumatic shock. I have to keep this shit up.
But what I found, I know, right? I know I'm starting to get shaky. What I found is the knowledge.
I get to go for my holy water and start sprinkling it around here. It's like
I found that having come from a networking background, and a Unix background, the networking background was significantly more useful in doing actual security things because I understood what the protocols were supposed to be doing, right? There's all the things about the payload and all, and that's all important. But like, if you don't understand that, that the sidewalk is moving, then you're probably going to fall down a few times. But if you understand you can step on the sidewalk and it takes you somewhere, then you've got the foundations down. And if you understand the networking bits, I've gone back and forth from networking and security a bunch of times in my career. That's longer than I care to admit, but but like I got into it very similarly. But what really just baked it in was the first time I had to deal with I think it was the I love you virus from a service provider perspective. Yeah. Right. So
mine was NIMDA. Do you remember NIMDA?
Oh, I remember. Yeah. Oh, yes. That's going to give me the shakes. NIMDA code red. Yeah. So that's what really solidified my security background. And there's actually a pretty good, I think it's a Datanauts podcast. Ethan,
is this the one you and I did where we talk about security without firewalls?
Right.
Yeah.
And so there's that one, and that's got some links to another talk I did at the Bro/Zeek conference in 2014. It's basically like, the firewalls are important and you need to know how to use them, but if you start to tease apart what they're actually doing, then you have much more in your toolbox to use, right? You understand host-based firewalls and other things like that. Those are both, I think, again, tooting my own horn here, but I think those are reasonably good resources to listen to.
Yeah, Ong, I hope that question wasn't overwhelming in the response. The problem with security as a topic, people specialize on very narrow things within security because there's so much to know. Greg mentioned cryptography earlier. Yeah, if you just sit and try to really understand how IPsec works, a fundamental, you need it, it's a building block, and you get stuck into all the different cryptography layers, what IKE versus IKE v2 are doing at the authentication, and then what the encryption layer is doing with IPsec itself, how that happens, how key exchanges work, the difference between certificate-based authentication and pre-shared keys. It's an enormous topic that can be very complicated, particularly when you start trying to understand the weaknesses and strengths of the various ciphers that go on down there. It can be overwhelming. So you got to kind of stand back and kind of pick some things to start with and get a sense of it, and then you're like, okay, I kind of get this, cool, and then you can move on and build with other things. It's a huge rat's nest to go down security as a topic.
More gin.
Yeah, cryptography stuff. If you really tease apart what IPsec is doing, there's like a 30% chance you're not going to be sane when you're done.
Yeah.
There's just so
Only
much
30.
there, and it's right.
It's mega fun though. The great thing about security is it's mega fun. There's never a bottom to it. Unlike IP routing, at a certain point in IP routing, you just get to the bottom of it and you know everything that's going on. About 60% of IP routing is actually up, but that's a different story for another day. But at the, an awful lot of IP security, there's just no end to it. It's just this, and it's a tremendous career to follow. Network security is very much in fashion again. It went out of fashion a few years ago, and it's very much back in fashion. And it's and the great thing about network security is it's a really good way to get noticed by the people in charge and to look valuable for doing very little work.
I think if you really want advice, just put up a board that has a bunch of different security things on it, throw a dart, and you'll have a good decision. Like, you can't really go wrong in that space. The jobs
don't get me started
plentiful.
on cloud security.
The jobs are plentiful. Yeah.
Yes.
Jobs are very plentiful in security, regardless of what discipline you go in. Network security, I think, is, I'm biased, obviously, but that would be my favorite because it involves the network as well. But know your protocols, and you're halfway there at that point. Understand the baselines. Look for deviations.
Let's argue about cloud now. I want to argue about cloud.
Oh yeah,
I want to have a good laugh.
You want to talk about Brandon's question, Greg, or something else?
I'm going to have to jump off.
No,
I got to jump out early. But
all right, Nick.
All right. Thanks.
Thank
Good
you.
to catch you again, Nick.
Thanks, Nick.
Yes.
Thank you.
See you, buddy. All right, let's Brandon. Hi, Brandon. We all know you from Twitter, et cetera, et cetera. Good to hear from you. All right. So curious on the panel's take on how the need for greater expertise and understanding in cloud networking, also public, private, hybrid, and multi-cloud, has been and will continue to progress. So cloud networking across all the different tiers of cloud, and then he continues. Although cloud native and platform services is continuing to grow, the vast majority of cloud workloads is still by far deploying servers, et cetera, into VPCs, which require networking. So, Brandon, one quick thing you can say in the chat here. If you want to actually pop on the Zoom call and talk about this, we can send you the URL. Sal, I see you're here as well. We know you very well. If you want to jump on, just hit us up in the back channel, and we'll shoot you the Zoom URL so you can pop in here and be a talking head and argue with us. Share with the group your thoughts. So anyway, no pressure if you want to or don't want to. That's fine. But Brandon's question. So networking, how is our expertise and understanding going to change? What do we need to know more over the next few years? And Ned, you're our resident cloud master, so therefore you have to have an authoritative and informed opinion about everything here.
Oh, sure. Yeah.
Now,
I mean,
hang on. Let's just do a bit of a promo here, because Ned is the host of Day 2 Cloud, which is the new podcast, our new cloud podcast in the Packet Pushers network. That's what his face looks like. I've never met him before. You know that, don't you? I just like to point out, Mr. Banks, that I've talked to him on a call every now and then, but we've never actually seen each other face to face. So.
Well, how about that? Here I am.
Yeah.
Exciting. And
with jellyfish on your shirt.
Well, yeah, got to keep it real. I only wear pictures of things that I won't eat, and jellyfish is amongst those. So it's a good start.
You're missing out. They do serve it in places in Asia.
Am I though? No, that's probably a debate for another day.
Yeah, perhaps, yes.
So, yeah, cloud networking is interesting because I think Brandon's spot on in saying that for the most part, most people are still consuming cloud as an IaaS model. So they're building their little networks inside a much bigger network, just an overlay on top of Azure or AWS's underlay. You certainly need to know something about how that networking works, but a lot of that is hidden from you. You don't have access down to the physical ports. You don't see anything below a certain layer. So you just have to go on faith that, Microsoft or Amazon or whoever or Google is doing networking appropriately, and that they'll meet whatever SLAs they've given you.
They're not doing networking appropriately. They're doing network for them. In other words,
their
the way
way
I put it.
Right.
So from a standpoint of network engineering, It's horrible. But they are doing what they need to do, like like limiting the number of routes you can put into a VPC. These kind of things that drive
there's
the
a
rest
lot
of
of limits. Some of those limits are movable. If you put in a nice request to AWS, for instance, when you first spin up an account, you get 5 VPCs in your account, but that is something you can bump up. Same thing with the number of, I think, elastic network interfaces that can go to some of the VM types that can be bumped up, but other ones can't. And once you reach some sort of limit that they have decided for whatever reasons, you are now at that limit. And the only way to change that is to move to a different cloud or pick a different size VM or whatever that restriction is. I ran into a real funky one with the security groups, which are network security groups in AWS. Basically, it defines who can talk to who over which port. And you can do grouping by metadata tags. So you can see anything with this metadata tag. Say a web server can talk to the middleware application server, which has this tag over this specific range of ports and this protocol. But there is a limit to the number of rules you can put in to a single security group before you overwhelm it. And when you're dealing with things like Active Directory, which is very port intensive,
a lot of ports,
you can quickly approach that limit depending on how you design your security groups. And I reached out to AWS. They could raise it higher, but they wanted a really good reason why. And I didn't, and they were like, nope, that's not good enough. And so they wouldn't raise it from 50 to I think I asked for 100, and they wouldn't raise it to 100 because they said, no, that's not a good enough business reason. Figure out another way to do it, basically. So, oh, okay. That's
what they're really saying there is you're not a big enough customer for us to justify.
Oh, yeah. No, yes. If I had not just been working for, a Fortune 500 company instead of working for a Fortune 50 company, they probably would have gladly bumped it up. And thrown a little more on top just to keep me around.
Just to keep you happy, just to rub
depending on your spend, I suppose. Yeah.
So Ned, your comment about not having as many choices made me think, well, maybe that's a good thing, because back to Ethan's comment about everybody having a Snowflake network, that's harder to manage and operate. So if you've got fewer choices, maybe that's good. But then it also sounds like you may have to come up with these crazy workarounds to meet your business needs, which gets us back to the Snowflake problem.
I don't know if it was a crazy workaround. It was more of you need to rethink how you're approaching your security in this particular case, which is fine. And I think the Snowflake thing doesn't work for the cloud because they deal in commodity and scale, and they have to support you. So they can't deal with these weird oddball things unless you are a sufficiently large customer paying them a sufficiently large amount of money. And then they'll make a few exceptions here and there.
Or they'll productize something new that if they've got enough people asking for whatever the oddball thing is, Amazon finally had the virtual gateway, whatever they call it, for example, because everybody's doing these weird workarounds to make it the same kind of thing happen. So they finally said, okay, and then they productized it.
Yeah, you absolutely see products getting released from any of the major clouds that were driven by one or two gigantic customers who had a very specific need. And they said, well, we built it out for this customer, so why don't we put this into a private preview and refine it and then do a public preview and then roll it out. And a lot of times they already did the hard work of figuring it out for that one customer. So now it's just a matter of slapping a product label on it. And if it's Azure, they're just going to call it exactly what it is. They don't get real creative with the naming, which I'm actually kind of thankful for.
Not a bad thing.
No, it's not. And then they roll it out in some betas to see if it needs to be refined, and then roll it out in GA over the course of maybe 6 months. And that's how you end up with stuff like Azure's front door service or AWS with the transit gateway, like you're talking about. That I think that was demanded by many customers, though. But I'm sure there were one or two real big ones that finally said, you have to put something in place. We can't deal with the fact we've got 600 VPCs we can't connect together very well.
So if you're approaching cloud networking for the first time, does this mean you're learning something new, or just sort of rethinking how you might design something on premise given the limitations you have to work within in the cloud?
I would say, yeah. I mean, you're definitely learning some new things. A big portion of the associate's exam for either Microsoft or AWS is understanding the limits of what the limits that they've put in place. I know I can't share the exact questions because I'm sure that would violate some terms and conditions, but it's absolutely a focus on all of them to know what are the SLAs and what are the actual limitations of the services. I suppose that's probably true of any certification, but it's especially important for cloud because you're going to bump into those. And then you have to figure out, okay, this is the way Microsoft wants you to handle this weirdness, and this is how AWS wants you to handle this. And then there's a lot of weirdness with connecting networks. So in AWS, you peer VPCs, but you can't do transit routing. So you can't have VPC A connected to B and B connected to C. You can't send traffic from A to C along those peering connections. You instead have to create a peering connection from A to C. But that's not the case for Microsoft. For Microsoft, you can do transit routing across their VNets, not VPCs. So that's a funky one. And then with Google's networking, I've just been starting to dip into GCP and the way they do networking, which is so strangely different than the other two. For them, when you create a virtual network, it's not region specific. You're creating a virtual network that exists across as many regions as you want to specify. And then you can take chunks of the IP addressing space for your virtual network and assign it to different regions. But you can have a big, 10/16 IP address space and carve out little /24 chunks to put in each region.
But it's still part of a /16.
You.
Yeah, it's still logically a /16. But
Right.
it's subdivided. This /24 will be in this region, this /24, but it's still one and the same broadcast space. Well,
exactly.
Pseudo
You don't have
broadcast
to
because
do...
it doesn't broadcast. Yeah.
Right. Oh, yeah. There's no broadcasting.
Yeah.
Then, from a networking perspective, it makes it a lot easier because you don't have to create any sort of tunnels, or you used to have to create VPN connections between regions on your own, and then they added like global VPC and VNet peering in the other two. But Google always just had that. Oh, you want to talk to this other region? All right, just send it to the IP address in that region. We've already stitched it all together for you. So there's these weird, slight differences that will have an impact on your architecture.
And that, boys and girls, is why you will never have a multi-cloud. That is why multi-cloud is not done.
Oh, no, but you will. And
yeah,
you will
but you
not like
will.
it.
Yeah. So Brandon brings up a point, and he had actually anticipated a point I wanted to make. Brandon says there is a ton of over-the-top products addressing limitations of the native networking services we're getting with the different clouds. So another consideration, we're going to need to start understanding how to operate over-the-top networking in cloud. Yes. So for example, I was at the ONU conference in New York last week or the week before, whatever it was, and talked to a company that's doing this. You probably heard of them, or you're going to hear about them, Aviatrix. That's their whole thing. They don't, you don't want to interact from their perspective. You don't want to interact with the cloud and all their weird, funky networking limitations that Ned was just talking about. Instead, what you want to deal with is them. Deal with Aviatrix, and they're going to abstract all that stuff away. You talk to the Aviatrix controller, and it's going to stitch together your multi-cloud environment with an over-the-top service that gets everything all plumbed up together and optimizes it for you and does it in a cloud native way as best as possible, where their whole thing is we're going to use cloud native networking as much as we can, and then for the things where we can't, we'll add some bits and pieces of our own. And now their argument, Brandon, which I think is interesting, the way you put this, the way you put it, it's like, are we going to have to add not only the cloud networking stuff, but this over-the-top service and have to learn that too? Aviatrix's argument is, well, no, you don't have to learn any of the cloud networking stuff. You just talk to us and let us worry about the cloud networking stuff. That's their point. So, which of course we all know, if you know how it really works, if you know how it's supposed to work, that's probably better. When inevitably the additional service doesn't work quite the way you want to, there's always some gotcha. But I don't know who else is out there besides Aviatrix at the top of my head that's doing that exact thing. Some of the SD-WAN providers are kind of doing that, but
I would say VMware and Juniper are also making that same argument.
Yeah,
about
that's right.
they're claiming that with
and
NSX
Cisco,
stuff.
with
NSX.
Yeah.
Juniper with
Cisco
Contrail.
ACI Anywhere. There's lots of them. A confusing plethora, actually.
Yeah, I have two concerns with all of those solutions. One is, what do I have to add to my cloud environment to make your solution work? For instance, the ACI Anywhere, I assume you have to put some sort of agent, or you have to install an agent on every VM that you spin up. And as far as I know, most of these services don't deal with the PaaS component of things, really. They're solely focused on IaaS, which, that's a problem. And then the second big concern I always have about abstractions is, what am I losing via that abstraction? Am I losing functionality because I now have to boil it down to the lowest common denominator? And also, am I losing visibility? I think, Ethan, you were sort of alluding to that. I have now lost visibility into what's actually going on under the covers. So when something inevitably goes wrong, how
Potentially.
am I able to
I mean, certainly if
troubleshoot
you
this thing?
abdicate your responsibility to understand how that cloud native construct in that particular cloud works, if you just release that and let your vendor, you just deal with them and let them abstract it away, then you are giving up knowledge. You are giving up inevitably something that's going to help you fix the problems that you're definitely going to have.
Mhm.
You know, unless the product is just amazing and gives you that much insight into what's going on and you actually know what you're looking at when they give you all of that information, which means we're back to square one. And now you do really need to understand all the cloud networking as it behaves in their different respective clouds.
Well, it gets very confusing too, because so for example, as Amazon's now introduced flow capture from their VPCs, so you can set the VPC up to stream NetFlow style or SFlow style, or whatever flow style you like, records away, which you can then feed into a inspection engine of some sort. You can send them to Kentic, and as we found out with an Extra Hot podcast recently, they now do packet capture, so you can actually specify packet capture equivalent to what a spam port is. Azure's got it announced, but it hasn't here yet, and GCP doesn't have it. So now what you have is, if you have a multi-cloud strategy and you want to build a security platform based on recording packets for heuristics and analysis, for malware analysis or deep inspection, you can only do that on AWS, and you can't until Azure puts it out and wait for Google or Alibaba to catch up, right? So you have this thing where you really want these features, but you have to wait for them to come out. So if you move away from, I generally think that most people would be better off focusing on one cloud and waiting the 5 years for features to stabilize. I mean, personally, I would just not do anything with cloud if I could help it, because it's going to be, there's so much movement and there's so much change going on that you don't know where you're going to be as an infrastructure space, where you're going to be in 5 years. It's not going to, are you going to be in serverless? Are you going to be in PaaS? Are you going to be in EaaS? Are you going to be running containers in the cloud? Are you going to be running containers on-prem? Nobody knows, right? There's no stability here, which reminds me exactly where we were in 2001 when virtualization was just emerging and co-location was just becoming a thing, and nobody knew what it was going to look like. And it wasn't until 2008, 2009 that VMware finally got their hypervisor to work properly, instead of it being a bit of a half-assed effort. And it, finally started to fire, and it was stable, and it didn't crash all the time like it did through most of the 2000s. And then we knew what the strategy looked like. It was going to be VMware, ESX in the data center, and away it went. And co-location became normal. There was enough power. There was enough cooling. The models stabilized. The bandwidth stabilized. And we're in that very early stage of cloud where we're still not there yet, right? There's so much changing, so much going on. And early movers are going in, and they're the true believers, and they've got the faith, and they're singing their songs, and they're hallelujah, and they're saying, praise the cloud, Lord, praise the cloud. But,
Amen, brother. Amen.
It is Sunday, so I mean, it all makes sense to me.
That's right.
Yeah, Jen. That's what I say, more Jen.
Greg, I think the problem though is that a lot of networking teams inside their organizations don't have a choice about sticking with one cloud, because developers are making that decision, or a business unit is making that decision about cloud adoption.
Yeah, that does seem to be the case. And for any sufficiently large organization, you're going to have different business units that have already made the move, whether you wanted them to or not. So how do you stitch that all together, or do you even need to stitch it together?
Just leave them to hang.
Yeah, I mean,
screw them.
No, you
don't have to care about them. Screw them, right? No, seriously, that is a perfectly viable business strategy. It's a perfectly viable business strategy to just say screw them. I mean, I've done that for years. We used to do it all the time back in the day when, a business department would come in and say, like, yeah, we just bought 20 PCs. Can you connect them to the network? No. What do you mean you won't connect? I said, no, not allowed. If you've got a problem, go and talk to the CEO. They'd go run off to the CEO, and they'd come down and he'd say, can you connect them to the network? I'd say, no, I can't. I haven't got any cables. I haven't got any NICs. I haven't got any, and the CEO would go back to them and say, can't connect them to the network. So, screw them. Don't be nice to people. It's not part of a networking job to be nice to people. Part of your job description is to hate your customers. You got to pick your moment. You've got to hate them, right?
That is one approach.
Ned
I
does
don't
not
know
endorse
if I
this message.
recommend it for anybody who hasn't already been in the industry for many, many years and has moved on from a customer-facing role. But do what you got to do, man.
It's true. I mean, look at these people. Some of these people come in and say, yeah, we've just deployed something in the cloud and now it's broken. And you want to look, and you look at them and you go like, well, I don't know anything about it. What do you expect me to do? Right.
So feign ignorance, or actually just be ignorant of the cloud.
Either works. Same outcome.
I suppose.
So
well, when they're
actually
like, hey, but you have this AWS certification behind you, that leads me to believe you might know something. So don't get certified.
No, certification doesn't teach you anything.
This leads to a bigger
That's like going to school and saying that school prepared you for life. No, it didn't.
The bigger question is, when you are trying to explore cloud, where the heck do you start? So, okay, Ned, earlier we were talking about, okay, just networking in the cloud, especially when we expand it to multi-cloud, is a fairly enormous topic. It's pretty significant. Then you get into all these other related services. Like you said, and the networking over the top stuff, it tends to be very focused on IaaS. They didn't even get into PaaS. Right, which is another huge world of services to get into. And then there's, the serverless approaches and how you deal with all of that. How wide of a body of knowledge is it reasonable? Is it one of these things where we're all supposed to know everything about everything again? Or is there a way to narrow it down and still provide the value that you need to provide to your organization?
I think you have to specialize in something, or maybe one or two things, and then just have a general awareness of everything else. And then if somebody needs you to do something that's outside of your wheelhouse, it's okay to say, I don't know how to do that, and we need to get somebody who does. I mean,
so define some
for?
Specializations. Give me some examples here in your mind of appropriate specializations.
IaaS is certainly a specialization. If you want to specialize in that and understanding how it works, deeply in Azure or AWS, that's a specialization that makes sense. They're certainly trying to drag in the PaaS stuff as much as possible, but aside from one or two really successful services, a lot of those are just being trialed out in some sort of testing environment by, various business units. So, if they want you to learn maybe Azure App Service, that probably makes sense. That's actually a fairly successful and well-adopted service. If they're pushing you to jump into, I don't know, whatever their newest weird PaaS product is, maybe wait a little while. Maybe that, just because it's new and shiny doesn't mean it's the thing that you should deploy now. Especially the serverless stuff, some of the functions and serverless databases. I would stay away from serverless databases for the next 5 years before they figure out how to do that appropriately. Because there's nothing more terrifying than the idea that my database might just not be there because I stopped using it for 10 minutes.
Yeah.
Time to warm it up. Yep.
It's like the other one like that is Pivotal. The Pivotal platform as a service product. That was, and they were all, and it was they were convincing customers to buy shares in the company, and now all of a sudden it's basically worthless to the point that VMware bought it. Just, in my opinion, VMware bought it just to rescue the companies from and it's a pretty good sales database. If you just bring them in, maybe they'll buy VMware and make money out of it. So there's lots of stories like that. And this is my point, is that my general advice on cloud is to ignore it for as long as possible and wait for it to stabilize. It's a bit like picking up VLANs.
That's impossible though, man. We can't wait at this point. We're past that. We were past this point 2 years ago, 3 years ago.
There's no compelling value proposition around public cloud yet. There's a lot of potential.
That everybody's using it in the entire world. Other than that value proposition, you mean?
There's a lot of startups using it. And there's a lot of people starting new things in it that don't really amount to much, but you don't see too many banking apps running the back-end transaction processing systems on the cloud.
Banking's very specialized with all kinds of weird rules and regulations around them.
Yeah.
If you look at
what about a music? So plenty of music apps are using the cloud, right? But at the end of the day, if a music app stops working, there's not going to be. Yeah, right. So what? If if Spotify stops working for a day, people are going to be upset. It's going to make the headline of the news. But you know what? Everybody's still going to get fed, and they're still going to be able to get home from work.
So Capital One is citing what sort of an example, Ned?
So Capital One is heavily using the cloud for many of their services, and for those services that aren't in the public cloud necessarily, they've adopted the cloud mentality for deploying their services internally and maintaining and modernizing them. I happen to know a couple of people that have worked at or currently work at Capital One, and that is very much their ethos. And I would call them a financial institution. So it's certainly happening. I would agree that there is no compelling business case if you're just going to consume the cloud as IaaS and trying to get rid of your data center. That does not make sense. If you are doing cloud appropriately and actually making the process and people shifts and the shifts in the application, in addition to moving it to a public provider, then it could certainly make sense. But the number of organizations that are doing that is relatively small.
So you shouldn't do
another
cloud.
example
That's what you
that
just
came
said
up.
is you shouldn't do cloud.
I think you should do cloud if you can do it.
You
If
just
you
said
wanna
that if you're
be-
only going to use the cloud to do ES, you shouldn't do it. But if you're going
Yes.
to the cloud by changing everything, but nobody is, so you shouldn't do cloud logically.
There are some large organizations that have made the change. If you
No,
if you
there are
review
some
this,
large organizations for whom a small part of the organization have made some change.
I'd
That's
push
like
back on
saying that. Yeah,
So
that's
the-
like
the
saying that
top
electric cars are
performers-
revolutionizing the car industry, except 98% of car sales are still petrol powered.
I mean, if you look at the State of DevOps report, where they poll a statistically relevant number of companies, the top performers are the ones who have adopted the cloud-like DevOps principles, and whether they're running it on a mainframe or they're running in the cloud, that's what enables them to accelerate and deliver, additional value to the business through their operations. So I guess the bigger argument there, or not even argument, the bigger point there is, if you're not going to change how you function from a process and people standpoint, it doesn't matter what technology you throw at it.
Yeah.
Yeah.
Which has been true for every technology transition since
Exactly.
Since wherever when mainframes were deployed, and then we went to microcomputers, then we went to mini computers, and then we went to desktop computers, and then we went to decentralized networks, and then we went to centralized networks, then we back to decentralized. That's true forever. There's nothing new. This is one of my favorite rants. There's nothing new about the cloud. It's the same old problems dressed up in a new outfit. And this one's pretty skimpy, and it's not very, very practical, right? And yes, there are organizations who can make a difference, but the benefits of the cloud are no different to the people who moved to the mainframe back in the 1970s, who could speed up their general ledgers. Like there was a time, believe it or not, where it took 3 months to calculate the general ledger. Do you know why the companies deliver quarterly results? It's because it took 3 months to tot up all the ledgers to produce a general ledger so you could submit a report to the SEC. Right. And then mainframes came along and totally revolutionized that whole idea. And you could calculate your general ledger on a monthly or a weekly basis. Right. And those whole that so-called innovation isn't new. It's just a rehash of the same old transition cycle in technology as we get a loop. The question here is, and the one that you correctly highlighted, which is, are companies capable? More correctly, the correct issue which you didn't address is, are IT executives capable? And the answer is no, they're not. They're generally incompetent. So,
but the thing is, you wouldn't recommend that somebody undertake a career in running mainframes, right? That's not where the industry is headed anymore. So why not, as they say, skate to where the puck is going?
Well, if you took a really long view here, you could say that mainframes could make a comeback. Right, because it's only a matter of time until centralized computing gets back in the game.
I'll have Ned and I are working on a podcast for Day 2 Cloud about mainframes moving to the cloud. So suck it, pal.
But I actually do agree that we are. I could see a return to centralized computing over time once people.
And a mainframe would be, and the advantage of the mainframe is that they have 40 years of development and iteration and stability. In theory, if they're smart, there's no guarantee that IBM's a smart company. There certainly is no sign of that in the organization. But the next obvious thing is that, high-speed quantum computers is a mainframe, right?
Right, and it may be an AWS mainframe that you've got on premise, and then a bunch of.
Well, it's more likely to be a quantum computer, a shared resource, like a quantum computer that has hundreds of thousands of customers sharing the same compute power. That would be, if I had to do some, open up the futuristic, the futurist kimono and go like pick some magic prediction out. That would be, where it's at.
You could make a solid argument that every AWS data center is essentially a mainframe. If you think about what the components are of a mainframe and how it's put together and how it's managed, you could make an argument that we have centralized. We're just centralizing in AWS and Azure's data centers, because you have a whole bunch of different tenants using the same hardware. getting time slices of it.
Yeah.
I make a solid argument there. I think the big
Yeah.
shift back to decentralization is really going to be as edge explodes. That is probably another like hour-long discussion, but
Yeah, I'm much more bullish about that in the short term. SD-WAN is increasingly moving away from being a router replacement to being an edge operations platform.
mhm.
Maybe that's a different topic to change to, but I'm convinced of that increasingly.
So, Ned, I want to hit on a topic that Brandon raised as an example of
I see that.
someone who's using cloud, Project JEDI. So you want to give people who haven't followed the story just a real quick on what Project JEDI is and then the controversy and so on.
Oh yeah, well, we're not going to be able to cover all of it here, but just the short version. So the Department of Defense, and I think especially their research and development arm of the Department of Defense, was offering up a contract to a single cloud provider for $10 billion over the course of 10 years. So it's really $1 billion a year. And also, if you read the fine print, they're allowed to back out of it at any time, whenever they feel like it. But the whole idea was that they were going to offer it to a single cloud provider, and that would be their cloud provider of choice. So obviously, the usual suspects came out of the woodwork: Azure, AWS, Google, and I believe IBM.
And Oracle.
Of course.
Oh, Oracle too? So
Oracle.
cute.
So
Uncle Larry missed out on a couple more billion.
Oh, he won't be able to buy his 6th yacht. I feel so bad.
Yeah.
So basically what happened is Oracle and IBM got knocked out of the running, I think, relatively early. Oracle did not take that lying down and filed all kinds of lawsuits, which were eventually struck down in court, as well as was their CIO or something mentioned it to Trump directly over a dinner or something. So, but that was all for naught. And then Google's employees staged at least one walkout and some other things to force Google out of the running for that. So they bowed out somewhat gracefully. And then it was pretty much down to Azure and AWS. AWS was the favored, or at least that was all the predictions were making, that they were going to win the contract. They are, after all, the larger of the two companies. But fortunately for Microsoft, they know how to play the government and enterprise game a little bit better than AWS does. And as a result, Microsoft was awarded the contract this past Friday. That was the 25th. So that is the official news. I am absolutely certain that AWS is going to challenge that in court, and this will drag out for at least another 2 years. But in the interim, yay for Microsoft. It's $1 billion, but it's not a happy billion. I
think the interesting thing here is that Microsoft didn't win it on its merits. It won it because Amazon lost, because Trump didn't like, and this is a straight up political play, Trump didn't like the fact that the Washington Post criticizes the current government.
Mm-hmm.
And he believes that Bezos, as the owner of Washington Post, must be out to get him. Honestly, I think Bezos couldn't care one way or the other, because he bought the Washington Post just as a bit of a fun social project to be nice to people, basically as, whatever. And I'm not sure that he cares one way or the other, but losing that contract has a lot of secondary impacts where there's a whole raft of other potential secret high classification projects that will happen around the world that Microsoft will now be positioned for, because they can say, we won the first one with the Pentagon in the USA. And the story, of course, was that the Pentagon chose AWS the first time and second time and the third time, until Oracle brought a court case and they still chose AWS. And now President Trump's got involved and forced them to choose Azure. So it's not a win for Azure by any stretch of the imagination. It's not a vote of confidence in Azure. It's actually sort of what I call an Oracle effect, which is where you've played the game better. You didn't win on your merits. There's no question here that, to my mind, that Azure is the Betamax here, and that the winner here is AWS. But that doesn't make it any less hurtful, the fact that they lost. Does that make sense?
I wish I could disagree with you, Greg, but I can't. My history with state government follows similar things. Nothing on this scale, smaller local state government here in my example, but I was involved with pretty large RFPs for telecommunication services. And how were they actually won? If you knew what was going on in the back room, all of the RFPs were written in such a way that they were fair to the letter of the law, as required, but that only one vendor was going to win the one you wanted to win. That's
Right.
how that was done. And the reason that was done, if you were, I was just a lowly engineer sitting around the conference table, but you could kind of hear as the higher ups would talk about these things. This goes back a lot of years, if any of you know me and know some of my background. So don't get excited. But what was happening was people at the top who kind of wanted things to stay the same with the incumbent telecommunications provider would talk to the leaders of the incumbent telecommunications providers saying, how do we write this thing so that when you guys respond, it's very obvious that you're the ones we need to award this thing to? It was never phrased exactly as obviously as that and so on, because that might get some people upset, but that's what went on. In other words, there were politics involved. That's how business gets done. I would have people call me up at times because my name was listed as one of the people to respond to for some of these RFPs, and they'd go, hey, how do I get in on this? How can I present to you guys? And a few of them I would say, you can. I'm just saying, without saying, maybe it's not worth your time. Perhaps you do not wish to pursue this.
Yeah. You should really
things I can't say, things I can't say.
Yeah. You should really consider your position in this now that you're coming from behind.
Right.
You're very late in the process. Yes.
Yeah.
In other words, you're 2 years late because we were talking to vendors about potential solutions 2 years ago. Yeah.
I ran into a similar solution or situations where the company or the government agency had to put it to RFP because those were the rules. But they had already in their mind selected exactly who they wanted to work with.
Exactly.
So regardless of the responses, it was basically already locked in. It was a done deal, which always made responding to RFPs, if you didn't know that you were the pre-decided one, a little dicey, because you're like, is it worth the amount of time and effort I'm going to put in? I worked for, a couple different VARs, and the decision was, is it worth spending a week writing up a 80-page response to this RFP, not knowing if the die was already cast, the person was already chosen, and you are just completely wasting your time and effort that could be spent chasing down new leads somewhere else. So that was always extremely frustrating. And it sounds like basically this was the same thing with Microsoft and AWS. Like AWS never entirely had a chance once Trump decided that he didn't want them to win the contract. And he's certainly not above, putting his thumb on the scale on anything.
Greg, I wanted to point out that I bet Jeff does care, because he's no longer the richest man in the world at last report. Bill Gates is. Now, I know Bill isn't as involved with Microsoft as he used to be, but still, Jeff might want that extra billion going into AWS, see if he can go past,
Yeah, like Amazon lost, what was it, $9 billion in a day of value, or some astonishingly large number.
Yeah,
when
which
their
means
share
you
price
should buy stock at that moment, because it's going to go
stock
back
drop
up.
7% or something.
In theory, yes, but there's no guarantees of that. That's the challenge that people are struggling with, is that AWS is spending a lot of money to build out its infrastructure. And the lesson from WeWork is that building out your infrastructure doesn't necessarily guarantee you a profit.
No, that's not the lesson from WeWork. The lesson from WeWork is that you should be brash, bold, and a complete moron, and you will get $1.42 billion to go away. I think you're right. What I learned. Where's my money? I can make terrible decisions too and lie about it. It's fine.
Oh, I just listened to a podcast where they dug into the history of it today, and this guy literally is a piece of work.
Oh,
but
I think my favorite, and I'll just leave it at this one. He created a separate company to trademark the We trademark, and then licensed it back to WeWork for like $80 million or something for the trademark.
$5.9 million. Yeah.
Yeah, just
he leased it back for $5
more million.
Yeah, but the point here is that in theory, he should have a board. There's a board who controls what the CEO does, right? And the board is, in theory, meant to have validated this to make sure that it is not a conflict of interest. It is obviously a direct conflict of interest. But the point is that the CEO is also the major shareholder, and the board has to report to the shareholders. And of course, the other big shareholder was Mayoshi-san in the SoftBank funds. So in theory, between the CEO and the chief investor, the board actually had no say, because even if they went back to the investors and said, this is a direct conflict of interest, the two senior shareholders SoftBank fund and the CEO himself, Adam Newman, would say, no, this is okay. So all of the checks and balances just completely failed in this case. The checks and balances, the board should have done something, and they didn't, but hard not to blame them, because even if they had said something, they would have got shouted down anyway.
Right. They had no teeth.
Yeah. It's an interesting thing. I mean, even at the end of it, Adam Newman is so bad that he is worth minus $1 billion to WeWork, because that's what they had to do. They had to pay him $1 billion to go away. So
Just
his
go away,
actual
please.
value to the company is minus $1 billion.
It's amazing. I could only dream of accomplishing such a goal.
Yes. I personally aspire to be minus $1 billion worth. Yeah.
It's a good personal goal. Getting back to the JEDI thing, I'm just curious what everyone's thoughts are regarding any sort of negative press or employee walkouts or activism at the Microsoft level. I mean, some portions of Microsoft are absolutely like rank and file. Yes, I will do, whatever. They're not going to do a walkout, but Microsoft has, over the last, 4 or 5 years, gone on a hiring binge of open source type developers who have these very strong opinions. They're, developer advocates, developer relationship type people who, for instance, Seth Vargo doesn't work there, but he's an example of that type of personality who, if he feels there is an ethical conflict, he will do something like pull his entire GitHub repository offline that Chef was using heavily after the whole ICE thing. So do you think there will be any similar reactions from the Microsoft camp now that the contract's been awarded?
No, Microsoft
as a corporate culture, has from the get-go been about sharp elbows, do business hard, and victory over everyone. Like, it's not just enough to win; they have to
winning at any price. And if that
else.
means taking money from criminals, they'll do that.
Yeah,
and they'll,
and unlike Google, who in their IPO statement of "Don't be evil," who had this sort of "we love the world and we want to do good things," Microsoft never had that aura about it from the beginning. So there may be pockets here and there of people who protest, and Microsoft will be like, "Okay, bye," and they will go along their merry way. Yeah, I don't anticipate the kind of backlash that Google got or Chef.
It's not the kinder, gentler Microsoft that we've all been led to
There's no kinder, gentler Microsoft. There's just
the Linux hugging Microsoft and so on. Ned, is that what you're getting at?
Yeah, we love Linux.
No, that's
all about making
Linux.
the world a better place.
You might see it as embracing Linux. I see it as killing Linux. Keep your friends close, but keep your enemies closer.
Oh, I don't think so.
Microsoft's
I think they just don't care about Windows anymore.
No, they don't. They're happy to have Linux and let people develop it for them, and they run over the top. It's fine. They're not interested.
They care about it from a rent extraction point of view. I mean, it's already a substandard product that doesn't work, right? So, but idiots continue.
Which Windows or Linux?
Windows and Linux to a large extent. I mean, let's face it, Linux on the desktop is a pretty big challenge. I think you're right. Conceptually, Microsoft agrees that owning Microsoft Windows for the desktop or the laptop is not a growth industry going forward. Remember what I said about if you're not growing, you're dying. And that's the way capitalism works in the modern era. And the laptop desktop market is shrinking as smartphones go up. Microsoft's not in that market. Therefore, you flip that business unit into rent extraction. And that's where you take cash out, as much cash out as possible for the minimum amount of money that you put in. So you kill off all your R&D, you kill off all your product management, you kill off all the overheads and do the minimal amount of work. And this is where the Edge browser comes from. This is an attempt to reduce the cost of Microsoft Windows by throwing out all the trash in IE6, slimming down the operating system to a smaller, tighter bundle. And that means it costs less to make and it costs less to support, right? So this new Microsoft Windows, they're talking about it's got some fancy name, imaginary name around it. But it's like you can get old Windows with all of the old compatibility stuff, but it's unsafe to use. There's a new Windows, which is everything taken out. But that's also a Windows, which is cheap to make, cheap to support, and cheap to maintain, right? So there's two sides to that coin. So Microsoft is basically saying, well, Windows is done. We'll do what we can to slim down that money, extract the maximum amount of cash. We'll use that cash to fund the next phase of development. That's called rent extraction. And the same thing's happening there with Outlook Exchange on-prem, Microsoft SQL Server on-prem. All that stuff is now in rent extraction mode. You won't see them not doing anything with their hypervisor. I've forgotten the name for it because nobody talks about Hyper-V. That's it.
Hyper-V,
no one talks about it anymore because like that game was done 5 years ago. So basically, Microsoft has always had a reputation for working with government contracts. When the US government in particular rolls over and says, Microsoft, give us the data on your customers, they go, sure. Do you want all of it or just some of it? Right? That's not a new thing. That's a 20-year thing. And if the British government rolls up and says to Microsoft, do you want it? They go, sure, here, have it. We're compliant with local laws, blah, blah, blah. That's if you're working for Microsoft and you have any delusions whatsoever that Microsoft as an employer doesn't hate you and does not care about you, then you should really reevaluate your life choices, because you are nuts.
Should I? Yes. So I'm going to push back on a bunch of that.
Yeah.
Since I know some people that work at Microsoft, and
I know what people think they do. There's a big gap between what.
Yeah, let him speak.
So
I won't.
disagree that. And many of them are very happy with what they do, and they do have some ethical concerns, and they're able to voice them. Does it go all the way to the top? Maybe not, but you kind of have to stake your claim out in different business units, and obviously there are different fiefdoms within Microsoft that have very different ways of doing business, and it's been a point of huge friction when they want to get something done that is cross those business units. Some of the issues that have happened in Azure over the years have been a direct result of the fact that one particular business unit didn't want to work with the other one. I mean, I can't go any more detail about that, but it's definitely true. I would also push back on the fact that they have abandoned some of the products that you mentioned, because the services that they're now selling as a service use a lot of those products. So all of the innovation that's been put into Hyper-V, Exchange, SharePoint, SQL, those are all about making them run better in a cloud service where it can be metered and billed by the second. So they're definitely putting innovation into those things. Now, for an on-premises deployment, they're definitely less concerned about that. Exchange 2019 has some really interesting requirements around what type of customer you need to be to even license it.
Yeah.
I don't remember the exact details, but it was something along the lines of you have to have like an enterprise agreement to even license it, and it has to run on a specific version of the Windows operating system. And it's basically because they're trying to get you to look exactly like how they deploy Exchange Online, because that's the only model they want to support.
Well, there's two sides to that. One is they want you to migrate to O365 for mail.
Oh, yeah.
But what they also want to do is reduce the cost of developing that product. And the way to do that is to deprecate all the legacy. Right.
Yes.
And to take out all the features that no one uses, throw those in the bin, simplify the pipeline, simplify the testing. And so when you do sell it, you make buku bucks, right?
Mm-hmm.
For the effort that you put in. So you're actually solving multiple agendas here. And so it's literally called rent extraction. You buy a product which has reached the end of its life, you sack all the developers, you put it in life support, you minimize the support costs, and just pull all the cash off it.
Right, and that's where I would push back, because they're not killing the product. It's not at the end of its lifespan. Exchange has a long lifespan. The on-prem version is, but they're going to be using at least some of the same developers to continue to develop the Exchange Online. And for that matter, I would say that most of their development shop for Exchange has already made the transition to working on Exchange Online. All the features that end up in the on-prem version have been running in Exchange Online for 3 to 5 years. So the priority of getting them down to the bits you run on the box, they don't care about that. And there's a lot of acrimony in the Exchange community about how that's happening. And it's kind of like the inevitable creep. There's nothing you can do about it.
It doesn't matter what you want. As a customer, you don't matter. Only what Microsoft wants matters. So stop fighting the inevitable and move on.
So Ned, I'm curious if, based on contacts you have at Microsoft, if you're hearing now the fact that Microsoft could potentially own this JEDI contract, will there be a pushback about we don't want to be involved with the Defense Department?
I have not heard anything in that regard. I mean, some of the teams I've talked to, they already worked with the government in various different aspects. So this is just more of the same. I mean, that's why I don't think there's going to be any pushback from Microsoft, because there was already Azure Gov Cloud. There are already plenty, there's a whole division of their sales force that works exclusively with government and state. So it's like, this is nothing new. It's just a continuation of what they already had. It's just that lately there have been so many people making these ethical objections about what companies do. I wondered if there would be, just a tag along effect to it at Microsoft, but I'm guessing no.
I mean, they've already had, months or even a year or more to voice this ethical concern about this contract. So if it hasn't
Mhm.
happened by now, I can't imagine it popping up at this hour.
Yeah.
Right.
And Microsoft doesn't care. They've been doing defense contracts for 30 years.
Hmm.
They've been completely immoral about where they get their money from. That pattern is long entrenched. Complaining about it 30 years after it started is gone. That's the only difference between Google and Microsoft, is that people at Google, these are the first contracts that Google is doing, not the last. All right.
True.
And if you've been doing them for 30 years and giving the US government or the Chilean government Microsoft support, then that horse is bolted. You can try and make that work, but I mean, protests for protest's sake can create a change. I mean, look at Greta Thunberg, for example. She's been able to turn protesting for the sake of protesting about environment and actually made it stick. So there's definitely value in protesting if you're that way inclined, but I don't think the organization is going to be listening unless something happens in society more generally, until outside the company says, we expect companies to act morally and according to fair rules in society. And
there's
then,
a bigger issue in
if that
capitalism
happens,
here, though, and the bigger issue is money. That is, you can look at a lot of companies and go, if the dollar sign is big enough, they'll make decisions they might not have otherwise made. And so I'm curious, is Microsoft public enough about their Azure spend, how much money they're actually making from Azure? Gross or otherwise, so that we know how much $1 billion a year for 20 years, what's the impact to Azure's bottom line?
Yeah, I mean, they do release their financial results, and Azure is broken out as a separate line item.
Yep.
It's not like Google for a long time, and maybe still hides in Google Cloud along with a whole bunch of other stuff.
Yeah,
Probably because
yeah,
it's
they're too embarrassed. Yeah.
insanely unprofitable.
Yeah.
You know? And what is it? 92% of their revenue comes from ads anyway. So why it's barely even a blip on their radar.
A lot of people will say that it's hard to imagine Google Cloud being serious when the company itself, the nature of the company, is to sell ads. And that's a
yes,
fair
that's their whole
argument.
business.
Yeah.
I don't know why anybody thinks
Whereas
otherwise.
AWS depends on, where AWS is the profit generator for Amazon, and so it needs that business.
Yeah,
and Amazon needs AWS for itself. So there's
Amazon
a very
couldn't
different.
afford their one-day delivery that they've rolled out across the country, or they're rolling out. They could not afford to do that if AWS wasn't helping pay the bills, because that is massively unprofitable for them to deliver something in one day. It makes no financial sense.
And there are fundamental differences in the way the business, if GCP wants to do something that might impact ads, it doesn't get to do that something. Then, whereas if AWS wants to do something that might impact retail, it gets a chance to fight that decision.
Right.
And one more point on the morality of tech companies. I'm glad that employees inside Google made these protests around JEDI, around Project Dragonfly, which was like a secret project to release a censor-friendly search engine in China. I'm glad they're actually forcing the company to live up to its espoused values. So if a company comes to market saying we want to be good, then you should be good. And so good on the employees for making Google live up to its values. Microsoft never had any, so it doesn't matter.
No, it did have
they
values.
Had different values.
Exactly.
Yes, you're right. It's a different set of values.
Yeah. Might not be your values. They might not be reasonably moral values, but they do have values.
They had a set of beliefs. Yes.
Yeah, it's called whoring. Anything for cash.
Oh, I liked having my MVP. I'm going to be so sad to see it go after today.
I think you've done a great job of defending Microsoft and standing up for them. They definitely should keep you around.
Oh, thank you. I will quote just that and send it over.
Exactly.
So we're getting down to the last minutes. Do we want to jump into a new topic or just continue down one that we'd already been talking about?
Let's circle around the table and just tell everybody where we're going to be live, because we have some events that are coming up near and far. So that'd be a good thing. So one thing, Ned, you and I are going to be at KubeCon, the conference about Kubernetes in San Diego in November. That's coming up, and you and I are going to be there. What's the plan, man? We're going to go and attend. I'm following you there like a little puppy, going, "Teach me the ways of Kubernetes, Ned," kind of thing. So, tell me what I'm in for.
Following the puppy is what you're saying. You're like 2 steps behind me on this Kubernetes thing. This will be my first KubeCon. I don't even want to get into pronunciations there, but Yeah. So I think the plan is for us to attend some sessions and learn some things, to talk to the vendors there and get an idea of what's happening in the space.
They are amorally selling whatever they can to whoever they can around Kubernetes. That's what's happening.
Well, we've established that, yes. And hopefully, live taping an episode for Day 2 Cloud about what we observed, some of the trends that are happening with Kubernetes, and maybe some suggested jumping off points for people who, want to get in behind you and be the third pokey little puppy in the parade.
Yeah, at least one podcast we're hoping to record. And if you're going to be at KubeCon in San Diego in a few weeks here and want to record with us and talk cloudy things, let us know. Let Ned and I know, and we'll figure out how to get that scheduled. I'm bringing a mobile recording kit, and that can happen. We can definitely do that. So just raise your hand, let us know, and you'll be a guest on Day 2 Cloud. Woo! Thing that can happen. So yeah, and
put that on your resume.
That's okay. Exactly.
Some people have. Yeah.
And if nothing else, Ned and I are going to be, at the end of the show, we've already got some time blocked off to sit and kind of review our favorite sessions, vendors that we talked to, and whatever. We're going to do a show just devoted to what we got out of that conference and whether we thought it was worthwhile or not, and all the rest. Have you actually done one of these before, Ned, this specific event, or is this going to be your first?
This will be my first KubeCon.
Yeah.
But obviously I've been to plenty of other conferences before. I know the drill. It's all about the hallway conversation. The food's going to be terrible. Right. And there'll probably be some attendee celebration that is absolutely not worth going to.
The food's going to be terrible. Welcome to every conference.
Now, Greg, you and I, the week before KubeCon, we're going to a Tech Field Day event. That is Tech Field Day 20. Those sessions will be live streamed. You'll be 8 hours out of your normal time zone. And
I won't be looking this good and fresh during that session.
So if you're listening,
if you're around Silicon Valley, around San Jose area, and you're there around that week, I'm actually flying in early. So you can buy me beers and tell me how awesome I am.
He needs that.
I mean, let's get together and hear what you've got to say. Like, which week is that? That's not next week. That's the week after. No, the week after
like
that.
A couple of weeks from now, right?
Yeah. So I'm flying in Sunday the 10th. I'll be available, and I've got a couple of slots for meetings on the 10th and 11th of November before Ethan arrives, and then we actually sit around and get drunk for a day or two.
Oh, that's our way. Yeah, we just get completely hammered out of our minds. Very professional. That's the plan.
Yep.
That never actually happens.
Yeah, we don't stream it live though. Normally, that sort of stuff. Yeah,
that would be fun.
And then, so then for me, that gets me into the December period where I'll be hanging around the Juniper Network conference in London, and then also the ONUG conference in London. I'll be hanging out there as well. I'll be splitting the days. I'll be at the Network event in Heathrow. There, if you want to come and meet me at the Juniper Network, and then I'll be heading to ONUG in Central London on the 4th and 5th of December. So,
Drew, are you doing any travel coming up? I've lost track. I know you've been out on planes a lot this year.
Yeah, the last thing I was at was VMworld over the summer. I don't have any immediate travel planned. We had flirted with AWS reInvent, which is coming up in December. We can circle back around that. But for the moment, I will just be in this office and traveling to the kitchen to make tea.
Yeah. Everyone keeps asking if we're going to reInvent. Ned, maybe we should talk.
No.
There's too much to do. It's just like I can't be on planes and traveling. The last 6 weeks of the year, it's just insane. Microsoft
I can't
Ignite's
think of
coming up.
Worst use of my time.
Really?
Yeah, okay.
Why not?
It's so
but Ned,
busy.
reInvent is going into Las Vegas and taking it over entirely, and everyone will be there. That's anybody, Ned. How could that be a waste of your time?
Because how are you going to find any of those people amongst 55,000 or 60 of your closest friends? The food is going to be awful times 20. It's impossible to get to any of the sessions you actually want to go to because
they're in 6 different buildings.
And they're in 6 different buildings.
Separated by about a half a dozen kilometers of space.
Yeah, the concept of actually having any kind of hallway track, being able to find any like-minded people, seems a little outmoded as well. So for a conference of that size, I would rather just sit back and watch the sessions later.
Yeah.
Fair enough. Fair enough.
I'm looking for small boutique conferences.
Yes.
Honestly,
where the
those have
unique
been fantastic.
Yeah.
Yeah. Like when I went to ONU in New York City, there was maybe, I think, 700 or 800 people there, something like that. I had some great conversations with some people that were doing network architecture stuff, solving problems, leveraging cloud, and all the vendors were very particular for that crowd. So there was some interesting conversations with them, as opposed to this endlessly huge hallway where you're like, well, let's see what these people do, and you just kind of wander
Let's walk
around.
for 5 kilometers and
overwhelming.
find our venue. Where's our room?
Oh, yes, that too. Yep.
Exactly.
And you sit down and go, wow, that's it. That's all the exercise I've had in 2 weeks. Now I've done it in 1 hour.
Yes.
Mm.
Well, all right, that brings us up, I think, to the end of our live session, everyone. So those of you that tuned in, there's been as many as 30 of you on the joining us for this experiment, and there's 22 of you now. Thanks. This was fun. We enjoyed doing it. We're going to take some of these discussions, and then it'll end up on our YouTube channel in the coming weeks. So if you wanted to catch up or see the best bits from the 2 hours we live streamed here, then that's coming. Just keep an eye out for it. DJ Drastic says, surprised in real life conferences are still a thing, to be honest. Yeah. So we kind of are too.
Indeed.
Fair enough. Events like this are more fun. And now that we've figured out how to actually do it, technically this is the first time we ever did this live stream and all that stuff. We maybe we'll do more of these now and again. It's actually pretty
Big
easy.
shout out to the people who've been asking us to do this for like 8 years or something.
Yeah, exactly.
We finally listen to our customers.
All right, everyone. We're signing off the live stream. We'll see you later.
All right.
Thanks, everybody.
Ta-ta for
Yeah.
now.